Our objective for today, I can graph and identify a linear equation using the x and y intercepts. Do it together. 1, 2, 3. I can graph and identify a linear equation using the x and y intercept. So the concept for today, we don't need a Fourier model because we started already with linear functions. But notice today, instead of being linear functions, it's what? Linear equations. Let's see. So today we're doing two things. One thing is that we're going to first identify what the x and y intercepts are of a given line. Then from there, we're going to graph a line using x and y intercepts. So just so that we can clarify how come now we're looking at linear equations instead of linear functions, let me go to the Fourier model really quick. Watch. Last week, we started graphing linear functions. Remember that? Where you created a table and then you plotted your points and you graphed your linear function. However, today we are in linear equations, not linear functions. So look up, please, to the screen. So last week, linear functions. This week, linear equation. Last week, linear functions. This week, linear equations. Last week, linear functions. This week, linear equations. Last week, linear functions. This week, linear equations. So, now for those of you that didn't catch it, here it goes. Linear functions requires that for every input, there's exactly one output. What does that mean? That we cannot have points stacked up one on top of the other, because when we do a scan through and do our test, if more than 2 points are aligned on the x value, it is not a function. Is that correct? But look at the equations. We have x equals 4. This is a vertical line going through 4 on the coordinate plane. That means it's a straight line up and down. And if we were to test it to see if it's a function, it was not a function. Does that make sense? Now, some of you are like, yes. So, for right now, let's just focus and say that today we're going to include lines of all kinds of directions and all kinds of angles, okay, or slopes. So with that said, copy these 5 steps, please. Step 1, use the cover-up method to eliminate one variable. Step 2, solve the remaining variable. Step 3, repeat steps 1 and 2 for the other variable. Step 4, plot your intercepts. And step 5, graph your line. These steps, guys, that I'm giving you, the 5 steps, is to graph a line using x and y intercepts. But what is the other thing that we're doing today, according to the objective? Aside from graphing, what are we doing? Identifying. So I'll show you how to do that right after you copy this. Go. All right, so 5 easy steps. Focus, please. Even though it says here a cover-up method, I'm going to show you 2 other different methods. Fairly simple. But before I get to that, first we need to identify what x and y intercepts are. So on the Q column of your Cornell notes, on the Q column, write this down, please. X-intercept. And for this lesson, I'm going to stick to red for the y-intercept, and I'm going to stick to blue for the x-intercepts. So y-intercept, what is that? Y-intercept is where the line intercepts, in parentheses, which means crosses. What does it cross? The y-axis. The y-axis. In case you forgot, when we have a coordinate plane, the coordinate plane has 2 lines, the x-axis and the y-axis. And here goes the y-axis. The y-axis is a vertical line. So whenever we graph a line and it crosses this axis, that's what we call the y-intercept. Okay? So if the y-intercept is where the line crosses the y-axis, what is the x-intercept? Exactly, where the line intercepts the x-axis, or it crosses the x-axis. The x-axis being the horizontal line in the coordinate plane. Okay? Copy that. Now that we have our definition, let me show you exactly what it looks like using a graph. Pens down, eyes up here. Don't copy this next part. This is just to elaborate on what I just said. Focus, please. Writing utensils down. So the first part, part of the objective, it says to identify the x and the y axes. So you're going to get some of these that they give you a line already graphed. Does everybody see the red line graph? Okay. And do you see the x-axis and the y-axis? Yeah, there they are. So according to the definition, I'm going to first identify the y-intercept. The y-intercept, we said, according to the definition, is where the line intersects the y-axis. That means where it crosses the y-axis, it crosses about right there. The coordinate for that point is what? 0 of x, 1 of y. Fairly simple? Now check this out. Now I'm going to identify the x-intercept. The x-intercept is where that same line intercepts or crosses the x-axis. Does everybody see where it crosses? Yes, I'm going to plot my point. There it is. What is the coordinate for that point? -2, 0. And that's how we identify the y-intercept and the x-intercept. Yes? You can start by finding whichever one you want first, but as long as you identify both. Now, any questions up to right there? No? Get your graphing paper in front of you. We're going to start with a medium-sized one. Only use one of them. And I want you to copy this next one, please. Example SQ. It says find the x and y intercepts, and they give us a line. Here's the line. You have your ruler. You have your graph. Let me zoom in so you can see where it crosses. Graph that line and identify your x and y intercepts. Copy that, and then we'll go over it. Go. Okay. Everybody should have already graphed the line, identified your x and y intercepts, right? Okay, share with your neighbor, see what they got. Okay, let's see. Y-intercept. Let's see, give me the y-intercept, please, for this one. Joseph? 0, 5. Hands if you got that. That is correct. Pass it to someone. X-intercept. 6, 0. Hands if you got that. That is correct. So you plotted your point there and your point there. Piece of cake? Yes? All right, on that same graph, I want you to plot these next 2 points. 3, 5 and 1, -3. Draw a line through those 2 points and find me the y-intercept and the x-intercept of that line. -3, 1. Sorry, -3, 1. Sorry, -3, 1 and 3, 5. Once again, the coordinates 3, 5 and -3, 1. My goodness. Focus, please. copy that. I'll give you some time to identify the x and y intercept. Go. Okay, let's see. For this line, I need the y-intercept. Can you give me the y-intercept for this one, please? America. -3, 0. Hands if you agree with that. Oh, +3. +3, 0. Hands if you... Oh, 0, +3. 0, +3. Hands if you agree with that. That is correct. All right. With that said, what is our x-intercept? Pass it to someone, please. Chris V. -4.5 and 0. Hands if you got that. Pretty close. If you got 4.4 or 4.2, somewhere around there, I'll take that answer. Let me zoom in so that you guys can see it. This is the x-intercept. It's about halfway there, right? And our y-intercept is right there. We got this? All right. So, yes.
How would you know, like, people draw their lines differently?
That's why that's what I'm saying. You got to be accurate with your ruler. Some of you that just get your ruler, just go like whatever. No, that's what we're trying to attend to precision with this, right? So make sure as you plot your points, try and make sure your line goes through those 2 points exactly at the center of both points. So let's see. Somebody asked earlier, Mr. Q, is the y-intercept always going to have 0 first? Let's find out. Let's see. Look at this one. When we're finding the the y-intercept, which one is 0? The x. Let's see for these over here. For the y-intercept, which one is 0? The x. Which one is 0? The x. Therefore, when we're finding the x-intercept, which one is 0? The y is 0. How about these? The y is 0. The y is 0. Because when we plot the point, the other value is 0. Everybody got it? Any questions with identifying x and y intercepts? No, Mr. Q. All right, so what is the other thing that we need to do according to the objective? We already identified. So now let's graph. So turn to the other small graph that you have next to that and copy this problem at the top. Yeah, the medium one. Yeah, you have a medium one right next to it, which is blank, right? Copy this problem at the top. It says example 1, graph the following line using the x and y intercepts. 5x minus 2y equals 10. Copy that, please, and then we'll get started. Be nice. Okay? This one it says, graph the following line using the x and y intercepts. 5x minus 2y equals 10. So, let me go over this one first, and then you copy right after. So, pens down, eyes up here. So, according to the steps I gave you, it says, use the cover-up method to eliminate one of the variables, right? So, and this is what I did with the other group earlier. I said I need an assistant, so I'm gonna get Boss. Boss, help me out. Go up to the board.
Yeah, boss. Yeah.
So I'm gonna do some math and magic here. So I'm gonna make a variable disappear. according to my assistant over here. Hold on. Okay. And since he's very tall and he's going to help me out, actually grab, let's see. Here, grab this so you can help yourself with this. All right. So I'm going to have my assistant cover up one variable so that we can eliminate that variable. Okay. Okay. So if you notice, he's trying to cover up the y. Did everybody see that? So what do you see that's left? 5x equals 10. Thank you, assistant. Thank you. All right. Yeah. We got it. Yeah. Nice job. So check this out. Look up, please. Since we had these left, do we know how to solve this? Yeah. Divide by 5, x equals 2. Therefore, this is my x-coordinate. X-coordinate is 2 of x, 0 of y, and it goes right there. Now, if my assistant was up there, I would ask him to cover up the other variable, but he's not. No, he's not. Just to save some time, I cover up the other variable. What do you guys see? Negative 2y equals 10. Therefore, divide by negative 2, divide by negative 2. Y equals negative 5. Therefore, my y-intercept is 0, negative 5, and it goes right here. And then I graph my line. Copy that, please. Yeah, instead of making a whole table and getting all those inputs, outputs, you can actually graph just using the x and y intercepts. Copy that, please.
Oh, are they always going to be like opposite?
So, with that said, look up, please. This, what we just did, is called the cover-up method, because what do? Cover up a variable and work on the other, right? However, pay attention, please. Another way that they're going to present this, let me show you, is like this. Look up to the screen. They're going to use this. A input-output table using only 2 values. Why do we need 2 values? Because we need an x-intercept and a y-intercept. So check this out. Let me ask you this. When the value of x is 0, what intercept is that? Tell your neighbor, when the value of x is 0, which intercept is that? That is correct. It's the y. So check this out. This is what's going to happen. Here it goes. We end up saying 5 parentheses 0 minus 2y equals 10. What is 5 times 0? We're left with negative 2y equals 10 divided by negative 2. Y equals negative 5. Then we go to the next one. Of course, that's going to be our x-intercept. And then we have 5x minus 2 times 0 equals 10. What is negative 2 times 0? 0. Divide by 5. X equals 2. So that goes here, and that's my x-intercept, and the graph should look the same. Copy this process also, please. All right, here we go. Focus, please. And here goes the third one. Look up. The first one was by cover-up. This is called by input-output table. And this one is just a method that I use. This is a Q method, if you want to call it. Check this out. So, do you guys see what I did? Okay. basically it's the same thing. The only thing I like to have them side by side. Here I have to solve for x. Here I have to solve for y. And that's just for me to keep organized. So here I just finished solving for x. X equals 2. Therefore it goes there. Divide by -2. Y equals -5. And that goes right there. And we can call that the Q method if you want. The Q method. Okay? So, we have all three methods. You can use whichever one you want. I just wanted to show you the different kind of presentations that you might see it. Okay? So, show me with your fingers how comfortable you are by graphing using the X and Y intercept. 1 being the lowest, 5 being the highest. I have some 1s, okay? 5s, 3, okay? All right, let's do one more. Turn your paper over. Do this one by yourself. Example 2. On one of the smaller graphs, copy this one. You don't have to copy the information. You already have it. Just copy the equation. Example 2 says, graph the following using the X and Y intercepts. -3x plus 5y equals 30. Go ahead, plot, solve for your X and Y intercepts, plot your points, and graph your line. Go. All right, let's see. Sergio, what is my X and what is my Y intercept?
Your X is -10 and your Y is 6.
Hold on. You said my X is -10, and what is the coordinate?
It's 10, the X1 is 10, -10, no, yeah, -10 and then 0.
-10, 0. So it's about 7, 8, 9, 10. And what is our Y intercept?
6, 0.
6, 0. Hands if you agree with that.
Oh, wait, no, never mind.
Nope. Who got something different? Dylan? 0, 6. That is correct. And your line should go through those 2 points. Our home plate for tonight is found on page 168. There's no tutoring today. Put away my rules on your way out. Have a good one. If I don't see you later, see you guys tomorrow. Bye.